Hello everyone, so today I'll show you how to solve Leetcode problem number 9, palindrome number. So the problem says that given an integer x, return true if x is a palindrome. An integer is a palindrome when it reads the same backward as forward. So 121 is a palindrome while 123 is not, because if I reverse 121, it is still the same thing. Okay, so in order to solve this, we're going to use an algorithm called the two-pointer algorithm. Now I'm going to show you what that algorithm does. So let me just open up my whiteboard. Okay, so let's say we have a number 121. We're going to have two pointers at the first digit of the number and at the last digit of the number. Let's name these I and J. Okay, so now what we're going to do is, if it is a palindrome, then I and J will always be equal. For example, 121 here is a palindrome, and this I right here has to be the same as J, because each time I am going to move I to the left one and J to the right one. So we're going to iterate through 121 until I is greater than J. So let's erase all this and I'll use a bigger example to show you. Say we have this number 1, 1, 2, 4, 2, 1, 1. My bad. That is a bad drawing. So we first have our I right here. Let's make I black. Now in another color we have J. So the black arrow will always be I, and the red arrow will be J. So right now, each time we're going to iterate, we're going to put this in a loop, while I, the value of, because I is a pointer right now, while the value of I is less than or equal to the value of J. Why I am doing this is because once we reach the middle of the number, which is 4 right here, we can stop iterating, because then we are repeating the other pointer's work. So this is our first iteration. We compare I. Right now I is pointed to 1 and J is pointing to 1. 1 and 1 are equal, so we'll shift I over 1. So now I is here, and then we'll shift J over 1. So now J is here. Now I and J are still equal because both of them are 1. So we continue this process and shift I to here and shift J to here. Oh gee, I and J are both the same again. And then we continue. And I is here and J is also here. Now at this point, I and J are both at the same value, which means that they have the same value. Now according to our loop definition, it was while I is less than or equal to J. So the next iteration, when J moves over here and I moves over here, at this point I is greater than J, which is not supposed to happen. So at this point we break out of the loop. Now, if there was any time that I was not equal to J, we would automatically return false, because that means that the number was not a palindrome. But since we've ended the loop and the loop has completely finished, then we can return true, because this number 1124211 is indeed a palindrome. So let's implement this algorithm into our code. So first I'm going to define my I and J. My I will start at 0, and my J will start at the last number. But how do we do that? By doing this, we will make x a string and name it nums. So basically nums is the same thing as our input x. However, it is a string. That way we can use its length and index. So J will be the length of nums minus 1. because indexing starts from 0, remember. Okay, and then we have our condition, while I is less than or equal to j. Now we compare I and j. If I is equal to j, if nums I is equal to nums j, we continue. Else, we would return false. And then at the end, after everything is finished, if we still haven't returned false, we return true. Now, there is a more optimal way to do this. Instead of comparing whether they're equal in and else, we can make the code more simple by just comparing whenever it is not equal, we return false. That way, we just add I and subtract j from itself, because remember we're moving them towards each other. I is going this way, so I is becoming from 1, 2, 3. It's getting bigger and bigger. J is going this way. So J starts from, let's say, 0, 1, 2, 3, 4, 5, 6. J starts from 6 and gets smaller and smaller. And then at the end, after everything is done, we return true. So let's test it out. And boom, it's accepted. And now you know how to solve this problem. Thank you for watching. Please like and subscribe.